Hello, Algebra 2 friends. We are here for another section, period transformations of trigonometric functions. Let's go. First, let's define period. The period of sine and cosine is how long it takes to move through a full cycle. This has been discussed a little bit previously, but I want you to see it on this graph here, where we can see how starting at 0 and moving through 2 pi moves up, back to midline, down and back to midline again before the cycle starts repeating. We don't always have to start at x equals 0. This green bar down here shows us that we can start at any arbitrary point on the graph and show that we can move through one full cycle until I get to a point where the graph is going to have to start repeating itself again. So even if I go from maximum to maximum, I'm still identifying the length of one period, which here I can see goes from pi over 2, because it's halfway across this interval of pi, to then, let's see, this is 2 pi plus another 2 pi over 2, so 5 pi over 2. 5 pi over 2 minus pi over 2 gets me 2 pi, which is also obvious and easier to read from 0 to 2 pi. Sometimes it's easier to look from maximum to maximum, and sometimes it's easier to start at x equals 0. You look at the point on a graph, which is easier for you to identify. When we do period transformations inside of a function, we need to remember that these are a horizontal stretch or compression. And when we've dealt with these in the past, I've got this graph here to remind you that here's a horizontal shift. And when we've dealt with horizontal shifts, adding 2 moves this function left 2 units. So we take the original parabola, which would live here, and it shifts left 2 units. Here's our new vertex. And we learned about how we would add 2 to move left and we would subtract 2 to move right. Likewise, when we're going to use a multiplication, which is what a stretch or compression is going to require here, so we're going to have a multiplication rather than an addition for a shift. But likewise, that does still seem to work backwards. So like when b right here being multiplied by the variable inside the function, when b equals 3, this is a compression. And when b equals 1/3, it would be a stretch. Notice that we can still multiply outside the function, and this is going to still be that vertical stretch. We can add outside the function, so this is going to be that vertical shift. And we can also now multiply inside the function. Notice that this is inside the sine function, so this is going to be the horizontal stretch. There is, of course, a horizontal shift as well. The function will eventually look like this, where we will have b times, in double parentheses here happening, x minus h plus k, and then we will eventually have that horizontal shift as well, where, again, everything is happening inside the function right there, inside the sine function. I have this Desmos link down here for you. I'll give that to you in a couple slides, where I've got sliders set up for a, b, and k. You can slide those around, mess around with the sine wave, see how b affects the graph and how it affects the graph with a and k in conjunction. I'll give that link to you in just a couple of slides. First, I want to look at how changes in period happen. So here what I'm marking up is one full cycle of this sine wave, starts at x equals 0 and goes to x equals pi. The period initially, the basic period, is always 2 pi in the parent function. This period is now pi. You can see the original parent function here going all the way to 2 pi. We're going faster. The period is halved. It's squished. It's compressed. The cycle is happening twice as fast. Instead of taking this long to go all the way up, down, and back to middle, it's going a little bit faster. It can go through 2 full cycles in the same time that the parent function goes through 1 cycle. It's going twice as fast. In the equation, we can see this piece a lot easier than we can see this piece. We see that speed in the function. Where the speed is doubled, we see a 2. Sine of 2x. The angle is increasing the speed of the function. Here we see one that is going slower. Again, in black, I've got my original parent function going to 2 pi. Here I can see the green is marking a full cycle. I'm going to look from minimum to minimum here, but I can see going all the way up and all the way back down. We can see 1, 2, 3, 4 pi that it takes to go through this full cycle. I start out with 2 pi, it's going to 4 pi. This is doubling the length of the period, which means it's going half as fast. It is slowed down. It's taking a long time to go through that cycle. The half is what we see inside the function. Sine equals half of x, because we are taking this angle and we're halving it to make it move slower through the cycle. So let's take a look at what this looks like in a function and how we can graph that. So here, hopefully you're already recognizing that we see a 2, meaning that this is going twice as fast. We are taking our original period and we are dividing how quickly we're going to move through that to equal our new period. So my period is now going to be pi. This sets us up with kind of a general conversion that we can use, where 2 pi divided by b is going to give me the period. Likewise, because of the rules of fractions, I can multiply both sides of this function by b and divide by period. I also have 2 pi divided by my period will tell me my b value. So we can use that later when we're writing expressions. But right here, I know that my period is pi. So I'm going to start at 0, and then I need to go up and back to midline and half the distance. So instead of making it all the way to pi, I'm going to go up and back to midline by there. So I'm going to go back to my midline, and then I'm going to fill out my maximum. I'm going to go down to my minimum and then all the way back up. This is my full period of pi. I can go ahead and just extend this pattern outward. So I'm going to extend to the right, up, back down, bottom, midline. I can keep going in both directions. Now I'm going to go to the left, back down, and my graph is a little bit in the way of my my pen. Sorry. There we go. Sorry, my little pen chooser is in the way of that, so I had to squish it up a little bit. So now I can go ahead and fill this out because I don't have all those intermediary points you've seen before. This gets a little inaccurate in my graphing. Better if I could go through and do all the intermediary points, but ooh, it was a little wobbly. Anyway, get everything in there, get my arrows on the end, and this is my new graph. Here's a function with a very different looking b value, but again, just remember that we can always rely on 2 pi divided by b is going to tell us our period. Here's my b value. I'm just going to go ahead and plug that in. 2 pi divided by pi over 3 is a compound fraction. I can deal with that. 2 pi divided by pi over 3. This is equivalent to 2 pi times the reciprocal. What I see here is that my pi values are going to cancel, and I'm just left with 6. So my period of my new function is 6, which is why you can see this x-axis is actually scaled not in full pi form radians, but in 6. You can see that the original period still goes to 6.28 because that is originally 2 pi, but I'm going to go now to 6. I'm going to still start at 0. And my full period needs to be that long. At this point, all I'm going to do is remember that my pattern of sine starts at midline, rises, midline, falls, and back to midline. So I know that halfway through this period is where I'm going to be back at my midline. Halfway through 6 is 3. So I'm going to look at this distance on my x-axis. I'm going to split it down the middle, and that's where I'm going to be able to put my next midline point. Likewise, halfway in this interval is where I'm going to hit my maximum. So let's see, this is 1, 2, 3. I'm going to hit that maximum at 1.5. Even if you don't pay attention to the actual interval and the values, seriously, just look at the number of boxes that you're crossing. This is 1, 2, 3, 4, 5, 6 boxes. I'm going to cut that in half to 3 boxes because that just helps me count and divide halfway across this interval. So at 3 boxes, which represents 1.5, x equals 1.5, that's where I'm going to find my maximum value. Similarly, I'm going to look in this interval, and halfway across, we've already determined 3 boxes, so 1, 2, 3. That's where I'm going to find my minimum value. And I've already mapped out 1 full period of this function. As always, I do want to make sure that I continue that all the way out. So every 3 boxes, I'm going to rotate between maximum, minimum, and midline. Again, I need to squish this up a little bit because I'm going to be all the way out there. So it's very similar to the original function because the period is shifted just barely slightly to the left of the full period of 2 pi to get to 6 instead of 6.28. Add my arrows as usual, and there's my new graph. Here's a graph where we're going to want to go from graph to equation. So this requires a little bit of detective skills. On this one, we're going to look at just a b only. In the next example, we're going to look at all of the values together. I'm going to look at a midline. I see a maximum, back to midline, minimum, and back to midline. That's going to help me recognize 1 full period of this function. I see that 1 full period is 4 pi. Remember that we had 2 pi divided by b tells us our period, but don't forget that we can rearrange that equation to also say that 2 pi divided by our period is going to give us b. So 2 pi divided by 4 pi tells me b. My pi's cancel, and 2 over 4 reduces to 1/2. So in my equation, I'm going to have the sign of 1/2 x. I don't have any other changes to this function. I can still see that my amplitude is 1, my midline is the x-axis, my period is the only thing that's changed in this. And it's definitely a sine wave because I'm starting at midline and then going up from there. Next graph here has a little bit more going on, so let's check this one out. The first thing that I actually want to look at is my midline and my amplitude. From there, I'm going to start then identifying what the period is. I see that I'm extending all the way from 2 down to -4. So my midline, as we've done before, I'm going to add these together and average them. 2 plus -4 is -2. Divided by 2 is a -1. So that's telling me that my midline is here at -1. Visually, that looks like I've done it correct. I can confirm for myself that indeed that is the midline, and therefore my k value is -1. My amplitude goes from midline and up. 2 minus my midline of -1 gives me an amplitude that's equal to 3. So I'm going to start being able to fill in some values where I know that I have y equals 3 times the sine of something x plus -1. Or I should just say -1 there. So let me erase that. -1. I still need to figure out what that something is, and this is where I need to investigate my period. So I can look at this value right here as my midline. It's great because it's right at x equals 0, so it's confirming for me that this is a sine wave and not a cosine wave. Having the midline drawn on the graph really helps me identify where I'm at. Maximum, midline, minimum, back to midline. There's my full period right there. My period equals pi. Remember, 2 pi divided by pi is going to tell me b. My b value is 2. So right there, I can go ahead and I can plug in 2, and this is my final function. As always, remember guys, you can hop onto Desmos and confirm what you've got. I do have some very generously timed experiments or exercises where I don't want you going to plug in every single possible equation into Desmos. But in the times where you've got that relaxed time to explore, I absolutely expect for you to do that. Use Desmos as a tool, everybody. All right, as always, email me with any questions if you have them or set up an office hours appointment. Bye.